Great. I guess
Dave.
I'll kick right off. Thanks for the opportunity, Victor and team, to speak about edge computing. You know, this is a huge topic, and so I've tried to boil it down into a couple of key trends and then talk about specifically what cloud service providers are doing. AWS, of course, is what I'm representing here in terms of services and so forth, but I want to make it clear that all of the cloud service providers have capabilities out to the edge that are similar to what I'll be talking about. So let me share my screen. Is this sharing all right?
Yes.
Okay, super. Again, a lot of material here. I will generate a PDF for a takeaway. I won't be able to cover all of this material, of course, in the time covered, but I did want to talk about some key motivators for edge, what we're hearing from customers and use cases, and the important trends around intelligent edge devices, if you will. First, I wanted to talk briefly about why we even care about the edge, how we think about distributed computing, pushing computing to the edge, or moving the compute to where the data is. We like to talk about three laws of distributed computing, right? So, law of physics, and that's of course latency and in bandwidth. Do you have reliable connectivity and so forth? That is a key motivator, always has been, for pushing out to the edge, whether it's serving users where they sit or serving data to the cloud from sensors, for example. Law of physics plays a role there, of course. Law of economics is super important when we think about the cost of compute and the cost of moving data around in particular. For example, in the case of sensors, you want to do a lot of local processing, local filtering, data reduction before you ever push anything up to the cloud. And there's all kinds of economics at play here, including in geographic distribution of data. And on geographic distribution of data, law of the land is increasingly important. Many regulatory constraints and other constraints around where data can reside, what you can do with that data, when you're there. We have to think about the legal and regulatory requirements around data in particular. So those are the three laws, and I'll touch on those again through this. The first major trend that I want to highlight here is the cloud. The boundaries of the cloud are moving, right? So if you were to ask me 5 years ago, where's the edge of the cloud? I might have said, well, it's probably out at our content delivery network, our points of presence delivering content, for example, streaming movies and so forth. And everything else out there is just sort of IoT and edge and not something that we put a lot of thought into. But starting, I would actually roll that back to maybe 2015, we started to do quite a lot in the IoT space, embedded stacks, IoT greengrass and so forth, that allow cloud-like APIs and capabilities to move out to the edge. And now, today, there's just this wide range of devices and services that go out to the edge. Again, we provide them at AWS. Other cloud service providers have similar capabilities, and I'll show some examples of those as we move forward. So that's sort of trend one, the cloud technology, cloud APIs, cloud governance, moving all the way out to the rugged edges we'll see in a few moments. The other important trend that we all know is intelligent edge. I mean, you've got now devices that have to sense all kinds of data in all kinds of harsh environments, collect that data, do some local analysis, or push it to the cloud for larger analysis, react to that in near real time or real time in many cases. And to manage that, you've got to have services that can actually manage these fleets of IoT devices at scale. Look for intrusions, for example, monitor them for performance, decommission them when needed, right? Monitor them and so forth. That's a huge challenge, and there's lots and lots of services that cloud providers have and that third-party software providers have in that space. It's a really fast-growing area. And when we think about edge devices, we have to think about where's the actual compute happening. Is it happening in the edge device in terms of inference? Is it happening in the cloud? Is there just something like a wake word and then the real activity happens in the cloud? Of course, not always. You have latency concerns as well. So lots and lots of action out there. Before we dive kind of deeper into those edge technologies, I wanted to do a very quick review of what is cloud historically. And the nomenclature that I'll use here is fairly consistent across cloud service providers. You know, you talk to Azure, you talk to Google, you talk to Oracle or ourselves, you'll hear similar things. Sometimes the words are a little different. But the idea here is that you have globally distributed infrastructure, and that infrastructure is set up to be highly available and reliable and typically concentrated in a relatively small number of global regions, right? So that global infrastructure is then supporting edge use cases that have existed for a very, very long time. I mean, the edge is not new, right? We've got Voyager 1 out there, absolutely an edge device with some intelligence in it that's been operating for 46 years and I don't know, 15 billion miles away. It's amazing, right? So edge devices have been here for a very, very long time. Now they're supported by these cloud infrastructure. If you think about how clouds are constructed, we use the term regions to mean like a geographic region. Let's say Virginia, for example, or Sydney, Australia, or Tokyo. These are regions in which we have infrastructure, and those regions are segmented into availability zones. This is really important to understand when we think about edge, is that when customers deploy, you know, whether they're academic customers, whether they're enterprises, they're going to deploy in a way that creates a highly available infrastructure using multiple of these availability zones, typically in a single region. Now, if they need to move closer to the users, kind of out to the edge, they may do this in multiple regions, or maybe they have, as I said earlier, this kind of law of the land where data has to be in a particular place. So maybe they need to have equivalent infrastructure set up in US, in Europe, in Asia to support those local users with those legal and compliance constraints, right? More recently, we have really been looking at how do we bring the cloud closer to users in areas where we don't have that large infrastructure available. And we can either try to land more and more and more of these regions that have almost a minimum size because of the availability zones, the amount of servers they need to have, or we can punch out kind of smaller, think of them as mini regions called local zones. And this is where we want to move closer to the edge. Let's say, for example, we have media and entertainment users in Southern California. Well, we don't have a region there. We have one in Oregon, we've got one in San Francisco, or maybe in Dallas, Texas with the energy sector, or Houston. So we want to push out to those areas closer to the edge with what are called these local zones. That's a recent thing. That's about 2019 that we really started to build those out. And we're landing those all over the place now, again, to get closer to the edge, not at the rugged edge, not right down at the device edge, but much, much closer from a latency perspective to these customers. And so, you know, 33 of them today and lots more coming. And, you know, you can see in pink what's coming in the future, and white. And these are places, again, where we don't have a full up region, but we've decided that we need to be closer to the edge by building out infrastructure in the form of these extra, you know, infrastructure, right? So now I want to talk about the actual edge, or what people will think about as in the edge. And historically, we've thought about IoT, right? These devices that are almost always connected, if not always connected. They're communicated to the network. They're, you know, the SCADA networks and so forth. But the edge has become super interesting in recent years, because what's been asked for by a long time by cloud users is, can I have the cloud in my own building, right? Or can I have it in the back of my truck? Or can I have it, you know, in my data center down the street? And what they mean is they want the same control plane, the same governance, the same way of managing the cloud as they're familiar with in the data center environment through cloud, right? And these have gotten super interesting because of the breadth of use cases, you know, all kinds of devices of all sizes. Some of these you would look at and say, oh, that's an IoT device. It's a sensor. It's a, you know, whatever. But many of them are much more significant. They're large pieces of storage infrastructure, or they've got a tremendous amount of compute in them, or maybe they're a hub for a robotics installation of some kind. And so you start to ask yourself, well, is that an IoT device, or is that a server? Like, what is that? They're all out there at the edge, right? So I thought I'd throw some terms here. And again, I'll provide this in PDF after the fact, because there's a ton of information and a lot of words here. But when we talk about edge, then We tend not to talk as much about IoT because that carries some baggage, if you will. People have an idea of what IoT is. We talk about edge devices. We talk about the hierarchy of edge devices, the hubs and gateways, endpoints, et cetera. We need to talk about services because an edge device is not just a piece of hardware. It has to have a software stack on it that's able to communicate securely with cloud and be managed, right? Compute at the edge, store at the edge, the intelligent edge I mentioned before. You hear these terms all the time when we talk about edge. Where it gets really interesting is when you're really out there at the edge, the rugged edge, the tactical and operational edge, if you're in the military world, the extreme edge, right? And these are edge devices that are really intended for extremely harsh environments. Think space or deep ocean submersibles, or maybe you're at the bottom of an oil well, or you're in a very high temperature environment in a manufacturing setting, for example. And then the far edge, like again, space station, Mars, um, absolutely the Voyager 1 out there, I would characterize as a far edge device that's been incredibly successful, right? So I'm going to kind of break this down into very briefly on how this is done with edge networks, how we think about the on-premise edge, that far edge I just mentioned, and then briefly touch again on smart devices, intelligent edge. So edge networks, I won't have much time to go into, but I'll briefly touch on what's happening there. Edge services, again, here's some terminology to take away. You need to think about edge orchestration, making sure these devices can be deployed, patched, managed, monitors, et cetera. They need to be scalable in many cases to millions of sensors that you're going to throw out there. They need to be secure, right? So edge security, super important. IoT, I've talked about before. I tend not to use the term IoT because it makes people think of devices and sensors and industrial IoT and so forth. You need to think about, like, what's the use model? Is cloud pushing the application down to the edge, or is the edge reaching back to cloud for a cloud assisted thing like training in the cloud versus inference in the cloud? And when we talk about like internally here and out in the community, we need to talk about domains and use cases. Like a domain might be an industry, a smart agriculture, right? Precision agriculture. And a use case might be crop yield, right? Detection, with drones or whatever, right? There's all kinds of use cases out there among the different domains. Again, I don't have time to talk much about the edge network. It's enough to know that there is a ton happening out there. You've got content delivery networks that have now become two-way streets because they also do high-performance ingress of data. You've got private 5G services. You've got wavelength, where we work with telco vendors, things like AWS Ground Station, which is a satellite management service, right? Kuiper that's going to be flying soon, of course, will integrate also with cloud services. So there's just a ton happening on the edge network side. LoRaWAN, another great example of this, right? But I want to move out to this true edge devices and services, just get some flavor of what's being deployed out there. So let's start with kind of on-premise. If you want to land some things in a building, for example, in an office or maybe in a data center, we have this. Our other cloud service providers have similar things. We call it AWS Outposts, and this is where you take a rack or a server or a small a server, and you drop those into maybe a data center or into a data closet, if you will, in a local site. So think of a manufacturing facility where you're trying to augment a manufacturing execution system, MES system. You could use local cloud infrastructure and then manage that in a cloud console just as though it was up in the cloud. It's the same APIs, it's the same control plane and so forth. The cloud service provider manages it for you, but it's in your facility. And there's a ton of use cases for these things out there. For government customers, particularly military, we talk about the operational and tactical edge. And here's where you take something like that outpost I just talked about, and you scale it into maybe a modular data center that you could put on a cargo plane and ship over to the desert somewhere, right? And so you've got a local edge data center in maybe literally a hostile environment, or maybe it's in a base somewhere. And this is a way to, again, extend the cloud into these other environments closer to the edge, right? Let's move out to the far edge of cloud. This is where it gets super interesting right now, and there's a ton of activity. I threw some terms out here that we keep hearing from our customers or from the government or from stakeholders, right? Rugged edge, think about something that's just not going to break if you drop it, from an airplane under a parachute. The extreme edge, where you've got incredible temperatures or pressures and so forth. Operational and tactical edge, those are terms used by the military. And dense edge, I hear that often to describe high performance computing or very, very dense compute provided in an edge environment. And these are becoming increasingly important in many domains. And the takeaway, again, is you need to have integration with cloud, you need to have consistency with cloud, and you need to be able to manage these things in the same way that you would have managed cloud. I won't go into great detail on these examples and services, but the rugged edge, again, take a ruggedized box, stuff it full of cores and SSD, put security capabilities onto it, make it connect up when it can to the cloud so that you can update it and manage it and then send it out in the field, right? And there's lots of form factors for this. We have something called Snowball Edge, that can be shipped like luggage, thrown around by the baggage handlers and still come up and be your local data center. These are often used as storage devices, by the way, with maybe some local compute to do things like data reduction, et cetera. But again, it's the idea that once it's fired up, it looks like it's part of your cloud infrastructure, but it's there on site. Going even smaller, we have something called Snow Cone. One of these has been flying around on the space station. This is, AX-1 mission showing there. But this is something that you could, carry in a backpack. You could fire it up, and again, it looks like a very small cloud region or availability zone that just pops up on the console. But it's on your desk or your backpack or floating up in the space station or what have you, right? Snowblade, again, this is another military implementation, highly ruggedized, highly secure, dense compute solution that can be sent out in the field as needed, right? So you can imagine many, many use cases for this. It's a data center in a box that's ruggedized and secure and meets requirements for the US military. Let's briefly touch on IoT and smart devices. I mean, most of us are very familiar with what's happening in the embedded world and the IoT world, so I'm not going to belabor this much. But the most important point about this is the trends I mentioned earlier in moving intelligence to the edge for an enormous number of use cases, whether it's industrial control, whether it's home automation, retail, financial services. There's just a ton of use cases and a plethora of platforms. What's been happening with these platforms, though, is they do tend now to look to the cloud service providers, Amazon, Microsoft, Azure, Google, of course, to get the IoT stacks because they need standardization. They need to be able to make it easy to deploy these things. And many of the customers that are buying and deploying these are also deployed on cloud, so they want a consistent interface. When we think about intelligent edge, of course, that's pushing machine learning, whether it's AI ML, whether it's generative AI, or whether it's simple statistical methods that have been characterized as AI, pushing them out to the edge, either by training models in the cloud and deploying those onto the edge devices, or using the edge device as a very lightweight sensor that pushes data to the cloud. There's multiple use models, but those are the two basic characteristics here. And again, we all know these use cases. I'm really excited because the intelligent edge is driving so much silicon innovation right now, whether it's low power edge devices with inference built in for specific use cases, or it's what's happening up in the cloud with the need for generative AI in particular infrastructure. And of course, there's services in support of that from all of the cloud service providers, AWS included. So I just want to close on that. This is a ton of material. I'll provide the PDF. Hopefully this has helped with vocabulary. And what we're seeing is the most important trend. And again, the most important thing from my perspective is that the edge, I don't even know where it is anymore, right? It's a continuum, there's the cloud, there's a sort of a foggy, and the edge keeps moving out, right? And so for a user perspective or a developer perspective, that's the way it should be. They should not see a significant difference between writing code and deploying to, let's say, a cloud infrastructure versus deploying way out in an edge device that may be, again, in a harsh environment. So that's all I know. I'm happy to take questions if there's any time left, but super exciting area for us as a cloud service provider, of course. I'll pause there.
Yeah, Dave, thank you very much. And we have good time for questions. We have 10 minutes for questions. It was, for me, a very illuminating talk. So Sadas Shankar has first question, and Kanat is second.
Yeah, hi. Hi, David.
Hi.
Actually, very nice presentation. So if I were to restate your perspective from a different angle, I would like you to tell me whether I got it right or wrong. I would say where the edge moves is a function of efficiency in compute and communication.
Yes.
Would that be a summary?
Yeah, I think that, well, that's
the
most important factor. You have to think about those secondary factors of law of the land, for example. Where can the data reside, for example, in the medical world? But yes, I would agree. Consistency and efficiency of communication is huge, as well as the ability to compute, the cost to compute, the density of compute.
And the law of the land is where you have privacy, because I didn't see you mention that, because when you're talking about health records.
Yeah, so law of the land could refer to legal constraints. For example, if you are doing semiconductor design and verification in Korea, the Korean government might actually have something to say about where that IP can be, in particular around memory and display. If you're working in genomics, then you may have regulators like right down to the state level in the US that have different requirements in terms of data governance, right, and curation and so forth. And every financial services, of course, every industry has its own constraints. Every government has its own constraints, export control, et cetera. So yeah, super important. It's a broad area.
Thank you.
Thank you, Sadas. Kanat?
So David, does Amazon have any data that they can share about the communication cost trends in terms of energy, bandwidth, etc., as cloud and edge diffuse towards each other?
Yeah, we do, not in absolute terms, but I will say that we have published data around our goals for climate pledge. Like we have a net carbon zero goal for 2040 as part of climate pledge, and we publish every year a report on that, and we publish what we're doing to reduce the energy consumption of communications, of storage, of compute. And also, increasingly, we're working with the community on the scope 3 to understand not just direct power consumption of the components that we put in the data centers, but also those scope 3 impacts. So it's a very, very important area for us. I don't have absolute numbers that I could share, but certainly I can provide follow-up with what we're doing in the area of power consumption or power efficiency.
Okay, I do have a follow-up question, So Amazon is pretty tight-knit about the proprietary hardware that goes on their equipment. So how do you protect your assets when they're deployed remotely?
It's a good question. Yeah, we have historically been somewhat tight-lipped, but I would say in the last 2-3 years, Amazon has been much more open. For example, we have a silicon innovation event every year where we dive quite deep into what we're doing with Annapurna Labs and our Graviton and Nitro chips and so forth, how we build SSD, for example, with our own technologies. And yes, that infrastructure does go out into the edge, right? So when we ship an outpost, it has custom hardware, custom silicon that we developed. Obviously, we want to protect our IP in the same way that any product company would, but we do ship custom chips out in those devices.
Thank you.
Thank you, Kanat. Zoran?
Question that tied a little bit to the previous one with no coordination and so on. David, if you can comment, what were the most effective models for bringing multiple providers? Because again, no matter how smart, how big, how rich, single company cannot do it, right? So what are the models that you see work in the past and might be extrapolated for the future? And I know it's a broad question, right? So if we look into kind of SRC as a model of bring together industry and so on the research side and so on, and lately so much effort into, let's call it lab to fab, probably the most overused term, right? What do you see as effective models of the past and of the future?
Yeah, and I'm glad I didn't use lab to fab anywhere in this presentation. Yeah. It was tempting. Yeah, so there's models for this in the open source world, right? So I would point back to when big data analytics became kind of the technology du jour 10 or 12 years ago, right? And you had the emergence of Hadoop, for example, as an open source environment for doing analytics at that time, and Spark and so forth that came along later. And of course, Amazon participates in those open source efforts, other cloud providers do. But what you quickly see happening is proprietary differentiated versions. So for us, Elastic MapReduce, for example, Redshift later for data warehousing, happen as you develop scale. So what you hope can happen is that the frameworks are somewhat standardized. For example, around Linux in the embedded world, it's always going to be a challenge. I mean, every large organization in the commercial sector wants significant differentiation in how they provide value to customers. And we're not going to create, of course, artificial barriers via de facto standards that we might create, but we want to quickly support customers like as fast as we can with new services. And if that means departing from the open source world and building something completely unique, we'll do it, right? There are certainly, and there always have been, third-party software providers, ISVs, and so forth that try to provide a consistent bridge across all of the cloud providers, just as they have in the embedded world in the past, across different processors, for example. And they're valuable, of course. But there's always going to be differentiated provider-specific technologies and capabilities that are unique to one platform. It's just always going to be the case, I'm afraid. I hope that helped answer the question. It's a long-standing issue.
It's a broad question. Appreciate, yeah.
Thank you, Zoran. Brett?
So, yeah, thanks. I think of the edge as like on one side of the edge, you've got a lot of compute infrastructure and compute capability, and on the other side, you don't. And typically, you're looking at things like agriculture, today, agricultural regions, remote regions, things like that. And it's related to Sadas's question. I'd like to kind of talk a little bit more, or hear you talk a little bit more about, are there challenges related to things like power, packaging, materials, ruggedization that would allow us to push the edge into regions that don't have compute infrastructure?
Yeah, absolutely. And technologies for very low power communications are super important. So LoRaWAN, for example, is a great example there of innovation that's made completely new use cases possible. And so, agriculture is a great example. You need to be able to, at a very low cost and with really little or no power available to you, embed sensors and controllers and things out into agriculture, into fields, right? And then you need to figure out what is the hierarchy of devices that's going to create the intelligence you need to do something meaningful there. Like, is there a central hub in the farm that's communicating, I don't know, with LoRaWAN or something that then communicates up to a low Earth orbit satellite that then communicates to a hub in a central location, and you have an increasing level of sophistication and hardware in that stack. I think this is a really important area of innovation for the semiconductor world, like low power, local compute to do even the bare minimum of inference and to communicate when possible with cloud-based infrastructure. And we see it. We see it all over the place. I think agriculture in particular is an area of innovation right now. Smart buildings too, to a lesser extent, but agriculture, weather monitoring, right? There's lots and lots of very, very low power sensor-based applications where, exactly as you say, you'll find compute on one side, but you'll find almost nothing down at the ground at the raw edge.